literature inspires hope, ignites imagination, and instills a love for learning. Good morning, everyone. It's my privilege and honor to welcome our esteemed chief guest, Dr. CNS Vinoth Kumar, Assistant Professor at SRM Institute of Science and Technology. Dr. Vinoth Kumar is a distinguished academician and a researcher who completed his PhD in Computer Science and Engineering, specializing in wireless sensor networks. His research interests include wireless sensor networks, cybersecurity, data encryption, artificial intelligence, machine learning, healthcare security, and big data systems. He has made remarkable contributions to the research community through numerous publications in prestigious international journals and book chapters. His research has been published in relevant journals such as Microprocessor and Microsystems, Journal of Intelligent and Fuzzy Systems, Journal of Database Management, and several other reputed international publications. His work span diverse domains including secure communication systems, energy-efficient wireless sensor networks, healthcare cybersecurity attack detection, coronary artery disease prediction using AI, chaotic neural network-based encryption, and advanced security architectures. His dedication to innovation and research has significantly contributed to advancements in computer science and cybersecurity, inspiring students and many of us. Today, we are truly fortunate to have such an accomplished researcher and educator with us. I am confident that his insights, knowledge, and experience will motivate and enlighten all of us. On behalf of our institution, faculty members, and my dear friends, I extend a warm and heartfelt welcome to Dr. CNS Vinoth Kumar. Thank you for accepting our invitation and for taking the time to share your valuable knowledge with us. Please join me in giving a warm round of applause as we welcome our distinguished chief guest, Dr. CNS Vinoth Kumar. Please, sir.
Very good morning, everyone. Privileged coordinator and head of the department is my close friend, Dr. Vijay Shankar. So thanks for inviting me here. And congratulations for the department for having an FDP for the welfare of students as well as the faculty. Privileged faculty member, delegates, for all, very good morning. And finally, the participants who are gathered, very good morning to everyone. So here, as a part of our FDP proposed title, Next Gen AI, am I audible? So I hope I'm audible now. As a part of Next Gen AI cybersecurity solution for intelligent and adaptive security systems. So I have been provided with the title named Federated Learning for Privacy Preserving Cybersecurity Applications. Being in a cybersecurity specialization or department, we are supposed to know the complete basics. So maybe you all from your pre-final years and final years. So what are all the cybersecurity applications and what is the current trend and why this cybersecurity got evolved right from various years, even we can call it as a decades. So as your fellow friend introduced me with the research area, wireless sensor network. That's the old traditional one. So from there it's been evolved and still it is booming now. The cybersecurity is still getting booming. And we are supposed to understand each and every baseline of this cybersecurity. So from the day-to-day lifetime, wherever we are moving, wherever we are going in day-to-day life, including the usage of gadgets, including the usage of mobile phone we can take, and applications whichever we are using, even in our home, the appliances whichever we are using. That's what there are various aspects this cybersecurity plays a role. That's what they are having the last term title on applications. So wherever we are going and using or percepting within our home or even in these premises where we are gathered at a seminar hall, there are some part of cybersecurity plays a role here. So without our knowledge, day-to-day activity we are using it. Simply if I want to say morning whenever we wake up, even myself and you all, while you are taking your mobile phone, just if you are just opening our mobile phone, it may given with code, PIN number or code. It's a kind of a security. Why do you want to give a security? It's for preserving our privacy. Simply for privacy. That's what we are having a title over here. I'm just going to justify the title first, and then we are heading towards the research aspects, whichever we are having. So, meanwhile, if you are looking for any home appliances in our home, sometimes we can take up some washing machine. Even it may have some kind of a child lock kind of a content. And if you are looking for a bigger refrigerator, so it may have some kind of a child lock or some kind of a security system where it should not get more vibration, say for an example as a washing machine, or refrigerator, it should not have some kind of high temperature or high voltage current. There the security applications involved. Every aspect I am saying. That's what this particular cybersecurity, it is evolving like anything in a recent trend, not only within India, across the globe, across various countries. And you are all privileged that you have taken a cybersecurity course and being in a cybersecurity specialization. And I am also proud enough being in a cybersecurity department. I am one of the active member in our cybersecurity specialization where we had different wings. Just I am going to talk only the basics here. It has different wings where it focuses in a different aspects. That's what I just given a gist of information. Whatever we are using in a day-to-day activity, including mobile phone, including smartwatches, everywhere the privacy matters here, including the data. Data is also it is an important aspect where whatever we are typing. Say for an example, if you want to apply for any exam, basically if you want to say. So as being in a pre-final year or final year, if you are applying for any exam, so straight away you will be giving your personal data. So the personal data will be carried out within our database here or server whichever we are having in the campus. So those data, how they are maintaining the privacy. This is one part which we need to understand. Similar way, wherever we are giving the data or wherever we are giving our personal data, including our individual mobile phone, mobile number, it is also kind of a personal data. Somewhere around within this hall, some 70 members we are having. These 70 members, if we can share our mobile number, it doesn't matter here. But someone who is neighbor or someone who is completely stranger, if they are asking for a mobile phone, we will not give. Their privacy matters there. So these are all the things which we need to understand. And that's what I just mentioned. Within this hall, if someone asking a mobile number, it doesn't matter. We'll be providing a mobile number. When I kept my mail ID, it doesn't have much bigger impact. So to a stranger, I will not share my mail ID. Very, very important. These are all the things which we need to understand with respect to cybersecurity. Where we are heading towards our topic, we need to understand this baseline very clearly. So, meanwhile, whatever the data, whenever you are filling or while you are applying or whenever you are filling up your any application within the campus or across any web pages, it will be asking many details. Nowadays, if you are taking up our government ID card, Aadhaar card, so earlier it was like all the 12 digit number it's open. Nowadays it's been masked. So this actually plays a vital role. That's why it got masked. So we can get the masked Aadhaar number, Aadhaar card or Aadhaar PEC card necessarily. So there we are maintaining our privacy standards, but in older days it is not the case. Similar way, every individual data I am meaning here. So there many research focuses are playing a role. So we can go to the introduction. If you are getting into our introduction, we can understand wherever we are using this cybersecurity. Already I have given you the vast intro that these are all the areas, these are all the places where we are using our security features. Similar way here, there is a rapid growth of cloud computing, IoT, edge computing and AI-driven services, and they increase the volume as well, as because even I just noticed we are having iOS lab here. Their iOS application development may happen. So individually students may develop the iOS application where it get launched and it needs a security first of all I am saying. Meanwhile, even within the campus, if a student community creating an iOS application, basically in campus many kind of startups will be going on. If they are creating an application, it is a load to the iOS database or app store. And similar way, within this campus, one or two applications if they are launching by today, across the globe how many applications will get launched in the app store of iOS. So similar way, the volume getting increased. Meanwhile, it needs a security aspects as well. And we are taking up, if you are taking up the cloud, so every day whenever you are opening or if you are just accessing your data, simply I can take up social media. Just if you are just opening your social media platform, where it creates enormous number of log files. There it is getting stored in the cloud. You do not know where it is. Luckily, this recent generation, I can say this recent generation, we have been gifted with this cloud. But in older era, so like our professors, including me, so in an older era, where we will be relying upon the CD, DVD, USB drive. If you want to carry any data, so I brought my USB drive only today. So these are all the older era. Nowadays, this cloud plays a vital role, and again, this cloud needs the security aspects. Similarly, IoT devices, edge computing, even AI-driven services. This is the recent era. Past 2 to 3 years, everywhere, anywhere, everywhere, we are speaking about AI. It's about artificial intelligence, and it was boomed right from some 10 to 15 years back, because this subject, the professors who were in this hall, they may very well know that this artificial intelligence subject, we had a core course before 15 years. Slowly it got boomed, where it has its own language, Prolog language, the same coding we are teaching still, but within this 2 to 3 years, this artificial intelligence plays a vital role and bigger role. So AI-driven services, it needs a security aspects. So now we can, and every domain or everything is significantly producing an increased number of volumes of data. So how to handle it and how we are going to preserve it, and thus we are going to rely upon this federated learning. We can have a basic understanding of this federated learning and its cybersecurity, how it is getting embedded, how it is working within this cybersecurity, and baseline for this cybersecurity, we may rely upon only the machine learning methods or machine learning concepts. So that's what we are going to discuss this. The traditional cybersecurity solutions rely on centralized machine learning, thus plays a vital role, or thus plays a important terminology here, centralized machine learning, that we need to understand very clearly. Centralized machine learning. So whatever the data, whichever we are catching, simply I just mentioned about iOS lab, creating iOS app within the campus. They will be creating a cloud storage or whatever necessary, or somewhere they will be purchasing a cloud storage. They will be storing up the data without any kind of segmentation, or they will be storing up straight away the raw data. These are all the issues which you are facing in the recent days or in the recent generation. Raw data. Just in the front slide, I just kept my name, mail ID, and other thing. But say for an example, even my data will be open. Say for an example, you can take up another example. So if you want to search for any research professor who is abroad, if you are searching for his information, sometimes the masked information will be available, but sometimes his mail ID will not be available. So there are various aspects where it get masked, and the data information or whatever the information which they are storing in their server, in their abroad university server, so it's completely managed by their own website, and we do not know what are all the technology which they are using. So similar way, this complete database we are calling as a centralized machine learning. Even the iOS data, whichever it is getting stored, or whatever the data, whichever we are collecting. That's what it's been mentioned as a multiple organization or devices in the central server. So this approach raising concerns regarding data privacy. I just discussed a lot past 10 minutes. This approach raises concerns regarding data privacy, security, regulatory compliance. This is one of the IP or intellectual property right. Regulatory compliance, whether it may adopt, whether whatever the proposed approach, whichever we are proposing, whether it may adapt to the current generation or not. These are all the regulatory compliances, and communication overhead, whether it can be feasible to use or not. What is federated learning? It's an emerging distributed machine learning paradigm that enables multiple clients to collaboratively try to share the global model without exchanging the raw data. This is one of the key terms which we are going to discuss in detail for this session, where it may exchange the data, it may collect the data from multiple clients, collaboratively it may exchange without exchanging the raw data. So say for an example, if you are providing all our data information, say for an example our name detail, mobile number, or our basic details, if you are providing to this particular FDP forum, so if someone tries to accessing about this data, where it will not be available in a raw way, in a raw data, in a common way. Instead, we are having this federated learning approach within this cybersecurity. So where it will act as a local model. From the multiple organization, it will act as a local model where it collects the data, and it will be having the aggregation model where it processes by themselves using the machine learning model, where within this processing term, where the information will be masked. That's what I tried explaining about this Aadhaar information and other thing. So whenever any third party or the other client, if they want to access the data, just only the necessary information will be given. This already we discussed, or this already we may know in SQL coding, the views concept. Whatever we needed, if you are selecting the row, only those information will be viewed to us. This is a kind of a views concept, but this has been trained using the aggregation model, using this federated learning approach. But basically it will not provide the raw data because of this security compliances and other thing. So this is what the introduction for this federated learning. So by integrating federated learning with advanced privacy preserving techniques, it may provide secure aggregation, differential privacy, homomorphic encryption, secure multi-party computation. So this particular federated learning becomes a promising solution for the remaining applications whichever we are having over here: intrusion detection, malware detection, phishing detection, ransomware, insider threat detection, UEBA, user and entity behavior analytics, and cloud security. So this particular federated learning is going to be the one of the important solution for this cybersecurity applications wherever we are using. So whatever we discussed from the very morning. So this is what the architecture. It's almost like a client-server model. How it works. How we already know in the networking client and server model. Similarly, it was working. There are various clients where they will be collecting multiple organization or multiple clients. I can mention as a multiple clients where they are collecting the data or where they are collecting the information in a local server. This is what it's been differentiated as different clients here. So local model, training and update, and finally it's been given to this federated learning process, FL process, where it is having the aggregation server and the model running behind it, the model initialization, it's collect the local model and it is just masking. Whenever necessary, any data if it has been fetched, it automatically will be providing only the necessary data whichever they are required. So why do we need this federated learning? So basically, it allows each organization to train the model locally and share only the learned knowledge, not the actual data, not the raw data. This is very, very important. So I can mention a real-time example for this. If you are looking for any home appliances or grocery store or bigger grocery store, just if you are searching in a Google or in an open internet or in a search engine, it may list down many information, but actual data will not get provided. These are all because of this federated learning. These are all because of this search engine which has been embedded with this AI technique, whichever we are experiencing. Simply I can say a page where just dial, it will not provide the mobile number sometimes. Again, we need to request for it. So then only it will be fetching the original data. This is the kind of example I am trying to mention. But actually, we here at this cybersecurity application, the data whichever we are collecting, it stores within the local server and it will get processed whenever necessary. The learned knowledge only it will be replicating, not the original data, not the raw data. So it got processed basically at this federated learning. What are the privacy challenge in modern cybersecurity? There is a difference given over here. Traditional machine learning and federated learning solution. But basically, traditional machine learning, I already mentioned you. Simply, I mentioned about the iOS app. If you are creating asset student community, the data whichever we are storing, straight away it will get stored up in the common database. That's what I mentioned as the centralized collection center. The sensitive and secure data will be available at the locally, it will be available within the organization. And there is increased risk of data breaches and privacy leakage. High communication and storage costs intended here if you are using in a local storage. Difficult to comply with these standards, HIPAA, PCI, DSS, these standards, because any kind of iOS lab or center of excellence if you are having, or if any data center if you are maintaining, we need accreditation for it. And we need a regulatory compliances. This is one such. HIPAA and other thing. Organizations are often reluctant to share confidential cybersecurity data. So whenever any client or other clients or any third party, if they are intended to collect the data from our local server, say for an example, for the entire campus, some local server they will be maintaining within our campus. Whenever they need, for even any corporate company, if they are fetching the data, whoever having higher percentage, then automatically they will be providing the entire data. Instead to provide only the 80% above students, they will be providing the entire data. So these are all the privacy challenges which you are facing in a common traditional machine learning process. What actually we are having is the federated learning solution. Data remains on local devices, it will not get shared up across the third party. Only model parameters are shared. I already mentioned you with different example. Even if you are looking for some data from the just dial, so it will not provide the entire data. Instead, it will be providing only the name, address, if needed the phone number will be provided. That's one kind of example I can see. So only model parameters are shared for the global learning. The learned knowledge, the processed learned knowledge will get shared. It enables collaboration without exposing raw data, improves cybersecurity, and finally supports a secure and scalable AI deployment. This is what actually we are achieving through this Federated Learning solution. And this is commenting learning objective. Already discussed a lot about this. Understand what we are understanding. So it will explain how the distributed machine learning enables collaborative threat reduction without exchanging sensitive organizational cybersecurity data sets. So far I just given you different example which it is in a real time factor. Just we can take up some kind of a test case or a use case, if you want to say, where we are having a bigger, we may have a bigger server or bigger rack within our campus. Bigger rack in the sense what I am trying to say, it's a actual server. Sometimes it may be we will be having in our campus as an administrator in an administrator block. Either it may have some kind of a cloud server or Dell server or some kind of a FDP server. There is a possibility of higher risk and threat reduction due to mail, via the mail, or due to phishing detection, or different example. There this federated learning, if you are giving this approach, federated learning, automatically the data will get masked up, and there is a lower risk of threat detection without exchanging the sensitive organizational cybersecurity data sets. And we can explore federated learning architecture, communication workflow, and finally we examine the real world security application, including intrusion detection, malware analysis, cloud security, and behavioral analytics. And finally, at future development, this emerging opportunity will be helpful with this federated learning ecosystem. And still we are getting into this commenting evaluation of cybersecurity. How exactly this cybersecurity will look like. So in earlier days, I can mention networks. In common way, I can say as a networks. From networks slowly evolved towards this wireless networks. From there, automatically, this networks and all necessarily needed security. And whatever the data which you are securing, basically, whatever the data which you are securing, it needs some kind of a security application. And slowly, it's been went into this wireless security networks. And slowly, it went for sensors. And while we are using the sensor, this intruder, basically this is what actually the starting point of this threat. The intruders, whoever tries to access that node or the sensor, they will be flooding their attack data or sometime compromised node for collecting the original data. This is how this wireless sensor requires the security in older days. Slowly, whatever data which we are passing towards the sensors, slowly it got changed as currencies, because through the sensor, currencies or sometimes original data or like I can say our raw data, sometimes our personal data, these informations were shared via the sensors. I can mention you some kind of example, agricultural sensor, where we are collecting the wind speed, or sometime we may collect the soil sensor information. So these are all the sensors basically. And finally, due to this sensor, many fraudulent activities started arising. So automatically, this has been named as this has to be provided with security or security landscape. Later, it's got evolved as a cybersecurity in common way, where this has been taken different dimensions. It includes first primary thing, intrusion and phishing detection. Basically, we can call it as phishing detection through mail, ransomware. This is the latest one, APT, advanced persistent threat, botnet attack, and social engineering. So these are all the attack deployment happened within this cybersecurity. And cloud computing and distributed infrastructure have significantly expanded organizational attack surfaces. This is one of the important points where I just mentioned you about this cloud server or Dell server or FTP server within the campus. It's been slowly scaled up due to the volume increased standard. Due to it got increased. So automatically they prone to make this expanded this organizational attack within the campus. Then this cybersecurity plays a vital role, and traditional signature-based security mechanism struggle against previously unseen attack. So I can mention you some of the common attack scenario or common attack method which we already know: brute force attack, another thing. So they struggled a lot for this unseen attack which are happening in the cyber level. And finally, AI enables proactive threat detection by identifying hidden anomalies and suspicious behavioral activity. I can give you a real-time example within our cybersecurity how the AI plays a vital role. So I can give you some kind of a gist of idea where a term called proper time series. Proper time series. So basically this is cybersecurity term only within the cybersecurity landscape. So but we are relying upon this data analysis or data learning which are available within the AI. So if you are collecting the actual data from the past years, so we can take up some area somewhere in other state or somewhere in some other country. We can take one kind of a region, Virginia, North Virginia. So at North Virginia, if you are collecting the complete data for some years, so exactly at the October or November month, either the cyber attack got increased. Meanwhile, the physical crime got also increased within the time span of the year. So this is what actually the data. And if you are looking back within the information, basically that is the winter period, where not winter, it's a rainy or winter period at those season. Basically at other country or European country or whatever the example which we took, North Virginia or anywhere, the people sits idle, they cannot come out. Then automatically they are working within the PC and they are start doing some kind of malicious things. This is one kind of a scenario. And another scenario, the people who are walking outside, the crowd is much less. Then the physical crime also increased. This is a kind of a statistics from different years I am trying to explain. Within this raw data, how we are going to process our cybersecurity model. This is what the gist of idea I am trying to explain. This is what the cybersecurity landscape I am trying to say. So this proper time series, past 7 years or 6 years, this has been processed as a model. Every time with some date information or the raw data, the cybersecurity application, it denotifies or notifies to the individual this October month at this particular day or time period, this threat is high, threat and risk factor is high. We need to be very cautious. These are all the alarm, basic alarm will get notified. This is how this machine learning and the cybersecurity landscape, like the cybersecurity, how it gets model training, how it is getting worked out. So this is what one kind of example. That's what I mentioned at the last point. AI enables proactive threat detection by identifying hidden anomalies based on this model training. What I am trying to explain, model training. So what are the challenges? So we do not want to talk much about these challenges. Basically, the data gets stored up in the centralized machine learning only. So whenever organization want to transfer the sensitive cybersecurity data, they need to exchange the data where it may have the higher risk factor. And what is the role of machine learning in modern cybersecurity? So basically, it enables cybersecurity system to automatically identify the malicious data. I just gave you the simple example just now, the real-time example. So identify the malicious activity by learning hidden patterns from historical security datasets. This is how it actually works. Basically, the supervised learning algorithm classify network traffic, malware samples, and user behaviors using previously labeled cybersecurity training data effectively. So this, I just gave you an example of this a physical crime and also the cybercrime which are happening in the October and November month, it will be in a peak. So that's what actually the samples. So unsupervised learning techniques detect unknown attacks and behavioral anomalies without requiring extensive manual labeled security dataset for training. So this attack information and behavior anomalies, it can be detected, it can be labeled as a security datasets if necessary, wherever necessary we can use that. And finally the deep learning also, it is somewhat much powerful or effective where it captures the complex data and future extractions can be done using this deep learning model. And finally, intelligent cybersecurity system continuously adapt to evolving attack techniques through automated learning, improved resilience, and reducing manual security operation. So these are all the common aspects. And how this centralized machine learning works. So there is a diagrammatic structure which you are seeing here. An actual machine learning ML model, it will work in this future only, where it will be having the own server, where it collects the different data from different nodes. Either it can be the mobile phone, or either it can be the sensor, or it can be different devices. It collects, it processes itself. This is older, almost I can say as a traditional model. In a traditional way, it was processing it. This is what actually the diagrammatic structure. And it prones to the, and it is attractive to attack, prones to the attack future. That's what we are getting into this federated learning. So this is what the example, and many information were given. So if you are using this centralized machine learning, it significantly increases communication cost, storage requirement. I just mentioned you about this iOS lab or iOS app development. So cost requirement also is high, and sometimes organizational policy, privacy concerns may be prone to risk factor due to deployment and etc. And still, what are the challenges associated with this? Centralized storage is one thing, regulatory compliances, organization frequently refuse collaborative learning. So these are the factors or feasibility factors which involves here. Massive cybersecurity data requires high communication bandwidth. So if you want to migrate the data from one server to the another server, it needs a higher bandwidth. These are all the challenges which has been associated within the centralized machine learning. And finally, it cannot efficiently support geographical distributed organization. It requires secure collaboration without compromising sensitive local cybersecurity information. These are all the challenges basically if you are adapting with centralized machine learning. So to avoid these kind of a thing, we are getting into a proposed thing, or we are getting into a FL model. So what exactly this FL doing, federated learning doing? Where it is having the, it is still we are using the same cloud structure, where it has its own global model aggregation over there, where similar way how we are having this centralized machine learning, we are having the global model aggregation over there, where different set of nodes or different set of client, we can take it as a devices as well. It collects the data individually within the client, at the client end, and at the local model it trains themselves, then it will get stored up at the aggregation, global model aggregation. Whenever any data requires by the different organization, I can say from client 1 to client 3, or client 3 requires client 1 data, it will not provide the entire information, or it will not provide the entire raw data. Instead, it provides only the necessary thing or locally available, now like from the aggregation model, only the necessary data you get stayed up. So this is how the federated learning works. If you are looking in deep, it is a distributed machine learning paradigm enabling multiple participants to collaboratively train models without exchanging raw cybersecurity data. So this plays a vital role, as I discussed various aspects while from starting of the slide. So it will not give the actual raw data to the other organization or the other clients. Instead of transferring data sets, participating client securely communicated only the model parameter, gradients necessarily, or weight updates, or aggregation servers periodically. So this is how it works. And still, aggregation servers combine local model updates into a global model, improving learning performance while preserving participant privacy and confidentiality. It also balances collaborative intelligence, cybersecurity effectiveness, privacy preservation, communication efficiency, regulatory compliances as well. This already I repeated, this regulatory compliances as well. So there is a difference which has been mentioned over here. So far we discussed how it looks like, where it is having the aggregation model at the right side, that is what federated learning. At the left side we are having the centralized machine learning, it's a traditional machine learning, where it needs higher cost, it involves the higher cost, higher bandwidth, and etc. etc. What is the benefits? So it preserves, FL preserves sensitive cybersecurity information, and distributed learning enables multiple organizations to collectively improve cybersecurity threat detection, violating the privacy regulations. And third one, privacy preserving collaboration enhances detection accuracy as well, and it will be providing us the faster accuracy. And federated learning significantly reduces risk associated with centralized data breaches. And finally, this cybersecurity application increasingly adopt FL to support intrusion reduction, malware analysis, cloud security, IoT production, and zero trust architecture. And this is how this FL architecture will look like. The core components of FL architecture, where it contains multiple clients, aggregation server, communications channel, collaboratively trained global machine learning model. Where if you are looking into the architecture diagram, where at the central server, still it is a traditional server, but it has its own aggregation model within it. At the client end, if you are looking in deep, every client has its own different devices and node architecture, and they are having this local model training within themselves, where they will be training their data within their local model, and they will be sharing their trained model with different parameters. That's how I just mentioned you about this SQL database, like almost like views and join, how you will be segregating the data, whatever necessary. If you want to view only the particular column of the data, you will be getting those data. Similar way, with the different paradigms and parameters, at the client end, the model will get trained. The trained model will be shared with this machine learning paradigm. At the machine learning paradigm, where it has its own model aggregation, almost it's been compared with our own brain. It's been compared with our own brain, where at the central server, it collects different organizational data, or sometimes it may has different client data. Whenever any third-party client requires the information from the aggregation server, it produces it doesn't produce us the raw data. Instead, it provides us the parameter which are added. So that's what has been mentioned. Each client independently stores sensitive cybersecurity assets locally, ensuring confidential information never leaves organizational infrastructure during model training. So many information was given, where it provides a secure communication protocols, protect model updates during transmission, preventing unauthorized interception, with no tampering may happen, no malicious things may happen, and even the malicious adversaries will not happen. Collaborative architecture supports scalable machine learning across cloud platforms, edge devices, IoT environments, and enterprise security systems. And this is what the step-by-step federated learning process, where it will get repeated necessarily. If the model to be trained, it will get repeated necessarily at a number of times. Where at the initial stage, central server initializes the global model with different parameters. At the client end, the local training will be takes place. Selected clients train the global model locally using their private data, where it may has its aggregation within themselves. And next, the model update. Clients send their model updates, either it can be the rates or gradients or in a different scale to the server. Just it shares their client data to the aggregation server. And at the fourth step, if you are looking in at the aggregation process, server aggregates the received updates to update the global model. So at the aggregation model, different set of trained client model or locally trained model, it will get stored up at the aggregation server. Where from the aggregation server, at the first stage, if you are looking in global model distribution, where it provides that the necessary data whichever required by the client. This is how it works, and if necessary, it can be repeated for multiple times. So this is how it works, step by step federated learning process. So this is what I explained as a point over here. And there are different classification for this same effort. So far we discussed how it works. So far we discussed what it can do, this FL, and in what way it will be effective. So these are all the things which we discussed so far. Now what are all the classifications which we are having in FL? And how it will play a vital role within this cybersecurity. So first thing is the horizontal FL. It supports organizations sharing identical future spaces while maintaining different user population and independently collected cybersecurity data sets, which it made it secure. So this is about horizontal FL. But while you are comparing with this vertical FL, it is possessing the different future sets, but for common users. But while you are comparing with this horizontal FL, the user population, it will be independently collects the data. But here it collects from the common users and it collaboratively trains. Collaboratively, it trains the machine learning model. While you are comparing the remaining classification over here, federated transfer learning, it addresses scenarios where participating organizations have different users, different future space, and limited overlapping cybersecurity knowledge available. Still, it collects the data and it processes by themselves. And fourth one, cross-device federated learning. It's almost like end-user devices where it connects the millions of mobile devices, IoT sensors. I already discussed about different sensors, deployed sensors, and edge computing platforms for collaborative intelligence generation. And finally, cross-silo FL, it supports the applications whichever we are having in a different organization. It supports enterprises like hospitals, financial institution, government organization, collaborative using relatively stable computing infrastructure security. So these are the classification of federated learning in common. How this communication route and model synchronization happen. This is the common paradigm that we need to understand, where global model is being locally trained. That's what we are calling as the local training. Then the model update, secure transmission, and finally it's being stored at the aggregation server. That's what aggregation. And finally, updated global model is available for us. So this is how this communication round and model synchronization happening. Just we saw it in the diagram already. you about this. Where the traditional learning, raw data straight away stores without the encryption. Here instead, we are having the encryption standard as well at Federated Learning, where it has its own local model training with model update. Whereas the application server, it aggregates model updates to build the global model. No raw data collected over here. Instead, the locally trained information will get shared with the aggregation server. What are all the features which you are having? Raw data stays within local organization. This is one of the important aspects. Strong privacy protection, lower the communication and storage cost as well. As we already discussed, if you are maintaining the centralized ML, it may not. It may leads to the high cost requirements, and finally easier compliance and data regulations. So these are all not appear much necessary. Yeah, here another one important aspect: differential privacy for secure collaborative learning, where almost like original data sets we are defining as a deep and model computation happening. Added to that, there is a random noise were added for more privacy or to preserve more privacy. Preserve this differential privacy in federated learning. This is a kind of a computation. Basically, this computation occurs whenever any machine learning or any machine learning model. This computational movement, it will be having the random noise, which it will be having the any mutant value to maintain the privacy preserving, or sometime we can say that as we can call that as like complex, increasing the robustness or increasing the complexity within the privacy data. That's why we are having this differential privacy for secure collaborative learning. And this is about secure multi-party computation. This is not much required. And optimization algorithm. Federated learning optimization algorithm. Like what are the optimization algorithm, optimization methods which you are going to see. So basically, it employs specialized optimization algorithm to improve global model convergence while efficiently handling distributed and heterogeneous cybersecurity threats. So basically, this optimization algorithm minimizes communication overhead, accelerate model convergence, and improve learning performance across the geographically distributed participating organization. Popular optimization methods are like FedSGD, FedAverage, FedProximization, FedNova, and scaffold and adopt gradient-based optimization technique. So selecting an appropriate optimization algorithm depends on data heterogeneity. So already we are discussing about this characteristics or the technique behind this effort. Basically, it provides the data heterogeneity, communication constraints, computational resources, and decides cybersecurity application performance. So, what exactly individual optimization algorithm performs? So, FedSGD performs one gradient update before transmission, requiring frequent communication but providing mathematically simple collaborative learning implementation. Coming to this, FedAverage performs multiple local training iterations before aggregation, significantly reducing communication overhead by maintaining competitive model accuracy. So next thing is the proximal. It introduces the proximal regularization term, improving convergence where when participating clients possess highly heterogeneous cybersecurity risk. And next thing is the NOVA. It normalizes local updates, reducing objective inconsistency and improving learning fairness among clients with unequal computational resources. And finally, FedOp combines adaptive optimization technique with federated learning, accelerating convergence and enhancing performance across complex distributed distributed cybersecurity application. So we can see a diagram now where we can understand handling the non-IID data and federated learning, how the data distribution occurs, how this optimization algorithm helps to maintain the data integrity and also the data distribution in a common way. So this is the comparison diagram which we are having. There are different future sets we are having. It's been categorized as different classes with 5 different names A, B, C, D, E, where it has its different features. So basically, uniformly distributed data from an organization, it's been trained locally at the local data, where it's been provided in a uniformity way, and it's been shared with the aggregation server, where at the aggregation server, the left side of the diagram, the data follows with the same distribution. We are not having the much usage of optimization algorithm over here, but while we are having the ununiformity, basically the data which it is not in a aligned way, or whatever the data which was provided by the different clients or organization, where we are terming that as a non-IID data distribution, where the local data having the different proximity level without any uniformity, where at the aggregation server, the class future A to future E, whatever it's been given to the aggregation server, it may differentiated in a different future at a different frequency level. Where we are looking in different data distribution across organization, still this FL learning can provide the security, can provide the aggregation server, can handle the data, and here at this non-IID data distribution, it's harder to train, and at the convergence level, it may lead to model bias and performance drop. But this IID data distribution, it provides the similar data distribution across all organizations. These are the data distribution between federated learning, handling IID data in the FL. And what are all privacy preserving cybersecurity application, where we are having a different example, different set of examples over here, where intrusion detection, malware detection, phishing detection, ransomware detection, entity behavior analytics. So basically we are aware this intrusion detection, where intruder attack, or I can say with an example, any sensor data whichever widely available, or sensor data widely collected across different client and server node, there the flooding may happen, or sometime DDoS attack may happen, where there this intrusion detection is possible. Here how this privacy preserving intrusion detection, which is allied with this Federated Learning, where Federated Intrusion Detection System, how it works, where it enables multiple organizations to collectively detect network attacks without exchanging sensitive data or security log datasets. So where each participating client trains local intrusion detection models using organization-specific network activities, preserving complete ownership of confidential cybersecurity information. This aggregation server, as every time we are discussing, this aggregation server combines encryption model updates to develop an accurate global intrusion detection model while maintaining organizational privacy. As I mentioned you, this FI improves detection of distributed attacks, including DDoS, denial of service, port scanning, and network reconnaissance activities effectively. And finally, this collaborative intrusion detection enhances threat intelligence, which it is sharing reduces false alarm and strengthens the cybersecurity resilience across distributed enterprise environment significantly. So this is with respect to the intrusion reduction. Due to this aggregation server, where it maintains the uniformity and it maintains this local trend model with different parameter, like collectively multiple organization or multiple environment or multiple client environment, they collectively addresses this attack whichever it is happening. So automatically they are preserving against any kind of privacy attack. So next we can get into this malware analysis. So basically we are aware about this malware. Either it can be the executable file or it can be the bootable running. We can take it in a different way. Sometimes this malware detection requires analyzing executable files, system log and behavioral characteristics without exposing confidential organizational information to external entity. This is how basically this malware affects the system. Or sometimes it may be the attack scenario may be happening within the server end. Sometimes the client from the client end they will start downloading the data, or sometimes it may be leaked by other phishing attack. How this malware attack were resolved? So basically, this Federated Learning enables organizations to collaboratively train malware classifiers within the local model while preserving privacy through localized machine learning and secure parameter sharing within the local model training itself. So local models continuously learn emerging malware signatures, behavioral indicators and malicious execution pattern. Everything will be identified. It will get managed from the organization specific security events independently. It depends on different organization, different organizational aspects. And finally, the aggregated knowledge significantly improves global malware detection accuracy against ransomware, trojans, spyware, worm and polymorphic malware variants collectively. So even and finally the federated malware detection supports faster identification of zero-day attack. So which it is very much familiar within this current generation, while minimizing communication cost and protecting proprietary cybersecurity intelligence effectively. So proprietary means like basically the data which it will be made within the lab environment itself, or it can be used within their app setup only. These are all proprietary. So it will be preserving, the data will get preserved, it will be preserving from the proprietary cybersecurity intelligence as well. This is about federated malware reduction. So far we discussed about two different applications. Remaining application we will be discussing in a short time. So I will be stopping here for giving some brief.
if you want to have a recap, so far we discussed right from the basic introduction, right from the machine learning paradigm and basic cybersecurity landscape, right from the traditional machine learning, how this federated learning works within this cybersecurity application or cybersecurity paradigm or cybersecurity landscape. From there we just discussed how this FL architecture works and how this aggregation server works, and within this FL architecture how the locally trained model works. Every information we discussed. With the continuation, we discussed this privacy preserving multi-party collaboration also we discussed, and finally we came for the application. So these are all the topics we discussed so far. So from the discussed topic, is there any questions to be raised? You can go ahead. So far we discussed a different set of information. So if is there any questions to be raised, you can go ahead. Resuming back the last, so in the continuation we can resume where we left. So here still the applications we are discussing over here. Federated ransomware. The term the ransomware, whichever we are seeing, so basically it was one of the traditional attack technique So if you are checking in detail, so basically asking for some kind of amount to be transferred. It's a kind of attack scenario where it encrypts the organizational data. Basically, it encrypts the organizational data and for releasing with kind of a ransom amount. That's what you're calling as a ransomware. So if you are taking up some example with respect to this ransomware, even I personally faced a ransom attack in the year of 2008 to 11, probably in those years, in the year of around 2010. So where the execution or the ransom attack execution may happen or may intrude via email or may intrude via a kind of a malware. In another form I can say, sometime this may be intrudes via the application whichever you are using in your PC. So the bootable or running scripts which it will get automatically adopts within our PC. Sometime it will execute at the boot level of OS. So it automatically encrypts the necessary data which it will not allows us to decrypt or which it is not allows us to access the complete PC, personal computer. This is how this encryption attack may happen. Only if you are providing some kind of a ransom amount, then automatically it releases the actual concern whichever it's being locked. So this is how the ransom works. And there are possibilities in what are all the circumstances it may happen. It disrupts business operation. Knowingly or unknowingly, if they want to stop a business factor, we can take up some example. Grocery store is an example. We can take a bigger grocery store kind of a Walmart or Reliance, whichever we are witnessing everywhere. So if you are putting their server down, even the Walmart if I am saying, or Reliance if I am saying, if you are putting their server down for some minimum of 4 hours, even we can take up the example of D-Mart showroom as well. For at least for 4 hours, what would be the revenue loss? So this is what disrupts business operation. So this is one of the important business factor or money factor which it involves within this ransomware attack. And basically this is like termed as one kind of a white collar crime and demand financial payments before restoring access to compromised information systems. So this is how this ransomware works. But as per our FL, Federated Learning, whichever we discussed in the previous session, Federated Learning enables collaborative ransomware detection using behavior analysis. I just gave you an example for the behavioral pattern with respect to the crime which was happened in different countries, including the time series I mentioned about it. So based on the time series, similar way, behavioral pattern will be captured, or behavioral analysis will be captured without exposing sensitive system logs or organizational operational activity externally. So this is how this federated learning. So every aspects so far within the application whichever we discussed, including intrusion detection, malware detection, as well as ransomware, it collects the data within the local trained model, and in different aspects within the malware, it automatically locally trained aspect it will be taken care. Here, based on the behavioral analysis, this ransomware exposing of the sensitive data will be omitted here. Basically, local models monitor file encryption behavior, abnormal process execution within the system or within the environment or the local environment, registry modification and suspicious network communication indicating ransomware infection security. So these are all the factors which we need to consider. As I mentioned you, different factors are involved over here. Abnormal process execution. While I started the session, I just mentioned you about the log files. Within the personal computer, or it can be the mobile devices. It is creating enormous number of log files then and there necessarily. So basically, if you want to find any kind of behavioral analysis, so we are supposed to check this log information. So if any attack happened or any attack detected or any kind of malicious aspects detected within our PC or mobile phone, automatically the behavior will get recorded within the log file. There might be a glitch within the log file. So actual process, how the monitored traffic flow which it is occurs. So there will be a glitch may occur. The glitch may peaks or it may downs. This is how we can identify. The glitch may record the bytes of information in a higher count, or sometime lower bytes count will be detected, or there may be the pass and hold within the behavioral analysis or in the log file. That's what it's been mentioned, where abnormal process execution. Abnormal process execution, the CPU time or traffic flow within the CPU time. So every information automatically it may has its hold effect sometime. Hold in the sense wait state. And similarly registry modification. However, we may all aware about this registry information, where registry data having different set of information, hive information, storage information, registered data, raw data. There at the registry level, there might be some kind of a modified data because of the glitch or attack happened. So as we are in the part called ransomware, whenever any ransomware encrypts our personal data within the PC, so automatically at the registry there will be a change may occur. So based on the registry log, we can identify or we can understand this ransomware attack so and so day within the particular time frame, this encryption got occurred. So this is how these are all the behavioral pattern within the process, within the registry, or suspicious network connection. Third one, suspicious network connection. So if any unwanted network intrudes, unwanted network communication or unwanted network request coming within the organization or to our PC. So we may identify this IP conflict in our own PC sometime, another thing. These are all unwanted network communication. These are all the indications where suspicious activity or suspicious behavioral analysis will happen to the individual system. Thus, it leads to some kind of a disaster. Thus, it leads to any kind of attack. And I am not meaning only the ransomware. It may lead to any kind of attack. So, based on this behavioral analysis, the local model monitor themselves, and the trained information will look for this behavioral pattern continuously. Then it may identify if there are any kind of circumstances which are listed over here, automatically it avoids this kind of a ransomware attack. This is how this FL works, Federated Learning works. And finally, this aggregated server, aggregated global intelligence, enhances early ransomware detection while preserving organizational privacy across healthcare, banking, manufacturing and cloud computing environment. So even while I'm starting the slide, even I mentioned you many different aspects, including our day-to-day activity, including the IoT sensors and healthcare, or sometime even the home appliances I mentioned in the morning. Everywhere this aggregated global intelligence enhances more preserved security. That's what many examples are given. And finally, federated ransomware defense strengthens collaborative resilience against rapidly evolving ransomware families through distributed AI and secure knowledge sharing mechanisms. So this is how we can prevent and coming to this one of the important aspects. This is one of the behavioral analysis, user and entity behavior analytics. That's what this is also one kind of FL, Federated Learning, where we can preserve the data securely where it identifies abnormal activities by analyzing authentication pattern, access history, device usage, and network behaviors continuously. Basically, I didn't brought my tools and all. So within this premises, if you are having the router over here, if you are having the router, wireless router, so Wi-Fi connections available everywhere within the campus. So there is a tool called Wireless Network Watcher, where you can download. That's open source possibly. So if you are just executing this Wireless Network Watcher, it just from the system, I'm just saying, it just connect to the router automatically. Why? Because I just connected my PC to the router. There different set of nodes will be detected and it will be listed. So there, if I am coming new for the first time here, my PC count will be counted as detected count as 1. If any professors or the faculty whoever coming, so whoever regular here, if they are connecting to the same wireless, the detection count may vary. So this is how we can identify the authentication pattern. Basically we can identify the authentication pattern. How many times the professor were connected to the particular router, or how many times the device were detected within this range. These are all the authentication pattern. So in another way I can mean you, so if you are going for a railway station, the railway station providing us the Wi-Fi networks for a free. So whenever we are going there, and if you are waiting for some time, if you are connecting to that particular same Wi-Fi router or first time into the railway station, then at the second time or at the number of times whenever we are going, the detection count increase automatically. So this is about the different abnormal activities where we can identify using different set of tools. First thing is the authentication pattern. That's what I just given you two different examples. One example via the router. If you are connecting your device to the different set of, if you are connecting your device to the router in different timeline, automatically it gives us the detection count and authentication pattern records different set of information. Meanwhile, I gave you example like railway station as well. There the free Wi-Fi router were free Wi-Fi were provided. So whenever we are going there, at first time if you are registering your mobile phone, next time within the same day or within a couple of days if you are going over there, automatically it get authenticated. In another way I can say an example, in our home router, whenever we are getting to our home, automatically it is getting connected. These are all authentication patterns. So within the configuration, this behavioral analysis can be captured in different way. Whoever want to access our home router, sometimes they may try to authenticate themselves, which it will deny the operation. So likewise we can identify the abnormal activities. This is with respect to single home and only few number of nodes and few number of participants. While we are considering the bigger organization, bigger entity, millions of users, if they try to authenticate to the network using the node activity, using the node connectivity, that authentication pattern may record enormous number of abnormal behavior. And next is the access history. So how many times we are crossing the railway station sometime, we can take up the same example, or how many times we are connecting to our own home router, so the access history will be stored up. Meanwhile, even our smartphone also providing us the data packets whichever coming inbound as well the outbound. So those information also will be stored up within the router configuration. So we can understand the access history, how much data were downloaded, how much data were uploaded. These are all access history. If there is any malicious behavior within this, sometime a node or user may connect only for 5 minutes or few minutes. They will be uploading a bigger volume of a data. This is a kind of abnormal behavior. This is what we need to understand basically. This is how this entire local model also will get trained their own client organization. whatever I just explained you an example, same set of local training can be made for this entire campus. So within a fraction of time, or a new user node who are connected to this organizational internet, if they are uploading enormous data in a single time, or sometime they will be connecting and detecting for some time, there are some kind of a behavior, abnormal behavior. So these are all can be captured using the access history. Device usage, that is completely different, where even this may be coming under the same railway station example or home router as well. And network behavior. So these are all the abnormal, these are all the patterns where we can understand the abnormal activity or abnormal behavior based on this user and entity behavior analytics. But basically this FL enables organization to collaboratively build behavioral model while preserving employee privacy and protecting confidential organizational activity records in a secure way. And third one, local behavioral profiles identify insider threats, compromising accounts, privilege misuse, and authorizes system access using organization specific cybersecurity datasets effectively. So there are many organizations. We can take up the example of corporate, where they are providing their own devices to the individuals. The individuals can use only their domain specific software in corporate companies. This is one such example for this user and entity behavioral analysis. So in a corporate company, basically we all may understand, so who are entering into the corporate company, immediately they will be providing their end user devices, including laptop or any kind of devices which they want to use. It will be configured in such a way that they can use their domain specific mail IDs, they can send a mail or receive a mail, inbound or outbound, only within this domain specific mail IDs only it will be working. This is about the corporate policy. This is what regulatory compliance I just mentioned. So in such a way, every organization, if they are restricting in such a way where they need to specific in privilege misuse, unauthorized system access, organization specific cybersecurity datasets, if they are going ahead with this idea within the local organization, we can secure the data. Same way, from the local behavioral profile, the model aggregation may happen. It improves the anomaly detection by learning diverse behavioral characteristics from multiple distributed organizations without exposing personal information. This is how it works. And finally, user and entity behavior analytics. It strengthens the zero-day attack, zero trust cybersecurity frameworks through continuous behavioral monitoring, adaptive risk assessment, and privacy preserving collaborative intelligence generation. So this is how this UEBA preserving the data based on this behavior based threat detection. And advanced cybersecurity applications of FL, Federated Learning. We can discuss a few applications. One such as this cloud security, enhancing cloud security using FL, Federated Learning, where cloud computing environment generate massive security logs. Already we discussed many times today, where enormous number of log files were created every day, and virtual machine events and network traffic requiring intelligent privacy preserving threat detection mechanism continuously. So how this FL works for cloud security, that we are going to discuss. So Federated Learning enables multiple cloud providers to collaboratively improve security model without exchanging the sensitive data, sensitive customer information, or proprietary operational data set. Same way, global cloud servers independently analyze authentication log, behavioral analysis within the cloud environment I am mentioning here, and virtual machine activity before sharing secure encrypted model updates. Meanwhile, the global aggregation of this FL improve the detection accuracy against cloud-based malware, privilege escalation attacks, virtual machine compromise, and unauthorized attempts. This is how it works here. So basically this final conclusion, federated cloud security supports regulatory compliance, data sovereignty, and collaborative cyber defense across hybrid, public and multi-cloud computing infrastructure. So this is the diagrammatic structure for this cloud security, for FL, Federated Learning for Cloud Security, where we are having the same set of aggregation server at the middle with privacy preserving aggregation server, where it is having a different data centers. Basically this cloud data may be maintained in a different data centers. We are aware, even we can call it as a meta, the social media platform, meta database, where they are maintaining different information in a different area, different regions of data center. Even we can take up the example of Microsoft, we can take up the example of Google server. We are they are not at all having only within a single country. The data centers they are maintaining in a different country. That's what the diagrammatic structure represented, different data centers, but where they are maintaining in a virtual manner. That's what VMware has been mentioned. They are maintaining in a completely in a virtual manner. So local security data, basically it creates, every data center creates a logs. Even I mentioned every time, different number of logs and network traffic information, authenticated events and virtual machine activity. So every information whichever which it's representing only the factors which I am asking, not the entire raw data. So this is with respect to the FL for cloud security basically. And coming to this IoT. So how this IoT applications enhanced with this FL that we can discuss. Before getting into that, we can just discuss different kind of IoT sensors or IoT environments. So whatever we calling as a node, sometimes we are calling it as a node, or whatever we are calling it as a different sensors which are going to collect the data, we can call that as a IoT sensors. So it may be in a different form, agricultural based sensors, healthcare based sensor. These are all coming under this IoT sensors or IoT environment. Or even security related data, whatever the sensors which was deployed at the army area. So if they are started collecting this temperature information at the army area or detection mechanism, so everything it is listed under this IoT sensor. But within this IoT sensor, security also is much essential because the data may get compromised. Even we can take up the bigger scenario where we all know about this Sindoor attack, where the precision attack how it is happening. Even the recent cinema we might have seen, witnessed in Jananayagan as well, the precision attack we might have witnessed. So this is actually the real-time army projects, whichever it is going, either any bigger organization, DRDO, government organization. This was actually the task which was given to the government basically. So which we witnessed in the cinema, the precision attack exactly the enemy, making the others as the enemy, or friendly fire activation. So these are all the precision attack within the node. I am mentioning about the node of the sensor. So whatever we are calling it as a tiny simple node, even the pacemaker also the IoT device, which has been kept within the in a health factor. Or the bigger sensor, we can call that as agricultural sensor, which may cost up to 10 lakhs as well. If you are deploying this IoT sensor, it may be the bigger one, where that IoT sensor, if you are deploying an agricultural field, without any power supply, it may last long even for 5 to 10 years. So those type of sensors also got deployed. Even 3 to 4 years back itself it got deployed. Without any power it will be works. But only aspect which we want to look for here is security. That's what we are having, this security landscape, and how is FL going to play a vital role over here. So we can check for this vast application, IoT application, how we are going to secure the data over here. So IoT devices continuously generate sensor reading, as I mentioned you. Either it can be the army area, either it can be the health sector, either we can call or we can consider agricultural land. The sensor data will continuously capturing the data, where the readings will be captured, communication logs will be captured, and behavioral information also will get captured. It requires intelligent distributed cybersecurity protection mechanism. How this FL takes place? FL enables edge devices to collaboratively detect cyber threats by preserving sensitive device information and minimizing communication overhead significantly. So it preserves sensitive device information. This is one kind of aspect. And meanwhile, at the local machine learning model, identify abnormal device behavior, botnet activity, unauthorized communication, and malware infection without centralized data collection process. So this is how every local machine, the own model training will happen. Within these factors or characteristics, abnormal device behavior, botnet activities, if any botnet activity or anything which it is automatically activating, unauthorized communication, and finally the malware infection. Same thing will get processed within this aggregation server, where global intelligence strengthens detection accuracy across heterogeneous IoT devices deployed within healthcare, smart home, industry and transportation infrastructure. I just mentioned different examples for IoT. It includes smart home as well, healthcare, industry and transportation as well. Even in the transportation, we are witnessing different aspects, including the sensors where even it is detecting the drowsiness as well. Drowsiness within the transportation. Even if you are taking up the bigger transportation, it has its various features. Particularly if I want to say, there is a concept called platooning. If anyone heard about this, you can search. If you didn't hear about this term called platooning, it's a kind of a transportation technique. It's a bigger wide research where they are tend to deploy within an Indian region, but it is hard to deploy here. But you can check for this platooning concept, where it is completely autonomous within this vehicle or transportation based on this IoT. However, for everything, the satellite is the satellite connectivity. This is going to be the major concern. But however, the term platooning, you can check for it in a future day or maybe at the end of the session. This is one kind of a transportation infrastructure. And finally, within this IoT security, the FL supports scalable, energy efficient and privacy preserving cybersecurity suitable for resource constrained embedded computing environment and edge network. This is with respect to IoT. And similar way, I just mentioned a different example here for connected vehicle. This is what actually the platooning concept. At the right bottom, I tried explaining about the platooning, where onboard unit will be there, where it will be acting as an autonomous vehicle. But basically we need the GPS module, that's what I mentioned about the satellite. And it needs a dash camera, TPMS sensor, where it will get locally trained. Whatever data to be captured, whatever data to be transmitted to the other device, it will get locally trained within themselves. But we need to understand different set of data are captured here. But earlier in cloud, only the data center. It is going to deal only with either log files, virtual machine data, MPEG, JPEG or MPEG or video files. But here for IoT, it is completely different. The environment is completely different. Where the smart home, camera information also a kind of a node, thermostat, smart light, voice assistant, Wi-Fi router. It's been locally trained. Data were available at the Federated Learning aggregation server. Whenever necessary, from my own mobile phone, if I want to control the smart home or if I want to control the air condition from here, then automatically the server will produce the necessary data. Then it activates themselves. Even we can take the example of IP camera, how it is working. So whoever witnessed about the IP camera, they may very well know about this. Based on the IP configuration, we can keep any mobile phone in the home. Using the IP camera itself, we can just witness whatever happening in our home. These are all a kind of a IoT environment. Coming to this industrial IoT, this is one such bigger infrastructure, bigger booming infrastructure or booming technology that we all are aware about. That industry version, different versions were there. Even now trending is industry version 5.0. So this is one of the important aspect where even the manufacturing unit also tends to play with these IoT sensors or basically the sensors. So right from the robotic arm, where whatever which was happened in older days using the manpower, nowadays it's simply converted into the machine, completely machine. Conveyor belt, CNC machine, temperature sensors. Temperature sensors also plays a vital role at the industrial sector, where it sustains in a different aspects and maintains the like without getting into the bigger disaster. This sensor also plays a vital role. There are different aspects. Different industry maintains different set of IoT sensors, and however it's been locally trained, it's been added at the aggregation server. Coming to this healthcare IoT, where this is another important aspect, almost kind of a life skill, heartbeat information, like pulse information. So if a person feeling drowsiness, or if a person having some kind of a medication illness, then automatically it can be considered or it can be taken into consideration based on this IoT sensor. So many of us wearing the smartwatches where it captures many healthcare based data. Basically the sensor, even the mini sensor whichever embedded within the smartwatch, those are all considered as a IoT sensor. So, and finally the bed sensor, and list were high even for older people who are having the deaf and dumb, they may have the different kind of a sensor. If we are exploring them, we may identify or we may get more information with respect to this healthcare IoT. However, everything model trained within the hospital environment. So within the local environment, locally they will be training the data and they will be capturing it. If any particular patient data must be maintained, particularly if any patient to be identified and monitored in the home premises, for them the separate sensors, accordingly the trained data will be stored within the hospital environment. So this is how this FL works with different IoT sensor, but basically for everything security is important. That's what we are maintaining this Federated Learning aggregation server, global model distribution. And finally the edge. This is not much detailed here. We are having the diagram. Edge devices we are having over here, where smart camera, IoT sensor, wearable devices, industrial sensor, local gateway. Why? Because it has to get connected with some kind of a router within themselves. Within the router, the data, like that's what I just mentioned. Within the router, the data will get stored at the aggregation server. Whenever necessary, we can fetch the data in a later way. So this is how it works. Basically, I just told you an example of agricultural sensor, which it can last long for. I can name it. I will name it. I will spell out the name possibly. So the agricultural sensor, where it may last long even for 5 years without any power, but it needs a kind of a gateway, local gateway, to store the data at a cloud environment or in a virtual environment. So even I can fetch the data even 6 months before whatever the temperature it was registered over there at the region, I can fetch the data. These are all the edge environment. These are all different examples. So however it will get stored up at the aggregation server. From the aggregation server, I can collect the necessary data using this FL, Federated Learning for Edge Computing Security. So what are all the benefits because of this? It is privacy preserved, reduced latency, scalable and distributed, real-time threat reduction and secure collaboration. So these are all the benefits towards this edge computing security. And finally coming to this zero trust architecture. So this is one of the trending attack scenario, whichever we all know with respect to this cybersecurity. Zero trust architecture. It assumes no user device or application should be automatically trusted regardless of organizational network location consistently. This is about zero trust architecture. Here authentication mechanism plays a vital role. So how this effort takes place, it continuously analyzes user behavior. The same thing whichever we discussed for UEBA, user entity and behavior analysis. Same way, authentication event and device activity without exposing confidential organizational secure information externally. So basically at the local server, this distributed behavioral model improved dynamic trust evaluation based on this pattern whichever we were discussing over there by loading the suspicious activity. Even I mentioned about the suspicious behavior or suspicious activity by the node, basically by the node across multiple collaborative organization or devices securely in an efficient way. So privacy preserving collaborative intelligence strengthens adaptive access control with continuous authentication, behavior anomalies detection with zero trust environment effectively. So this is what the diagrammatic structure. Earlier we saw cloud and next we saw the IoT environment. Now we are getting into this zero trust architecture where we are having a different set of information. Rather at the cloud we saw only the data center, and at the IoT we saw only different aspects as because IoT sensors plays a vital role in different area, and even we saw the edge devices at the third application. At the edge devices we discussed about industrial sensor, IoT sensors, smartwatches, IP cameras. These are all the things which we discussed at the edge devices. And finally the cumulative work or cumulative architecture which you are seeing over here, where at the middle we can see zero trust control panel, where basically it needs to check these aspects: identity verification, device posture assessment, context and risk assessment, policy decision point, audit and monitoring. This is what actually the control plane. So this is one of the gist or heart of the information for this zero trust architecture. Even the terminology also it's been given. Who is going to intrude or who is going to access this environment? What is this device posture assessment? How many connectivity or how many times it's been connected, or analysis, behavioral pattern, that will be captured over here. Then context and risk assessment, where and when it's been connected, or where and when it's been compromised, every information to be taken care. And fourth thing is the policy decision point, audit and monitoring. This is with respect to the organization part. So with this context, at the second step, if you are looking in, continuous policy evaluation will be maintained across this particular zero trust architecture with respect to the federated learning, because every corporate company or every bigger organization, they will be having their own policy regulations and other thing, etc., where it has to be followed continuously. That's what this zero trust policy engine works at the middle. So at the left pan, if you are looking for who are all going to be the end user. So already we discussed, so users and devices. At the enterprise level, even it can be the corporate or it can be the educational organization or the student community or app level end users who are registering to the devices. So those are all called enterprise user. It can be the employees or administrators. And next thing, the managed devices. Here one of the important aspects, managed devices. If I can call this small recording unit in front of me, this is a kind of a managed device. And I can say another example for managed devices. This is also a kind of a managed device where it's been configured and it's been set up and it is working in a correct way. This is what managed device. And in another way I can say the camera or this biometric, face recognition biometric, that is also a kind of a managed device. Those are all called managed device. Laptops, smartphones, tablets, those are all common entity, but in specific managed devices, these are all the things which it intended to do so. What are all the activities it needs to do so. And those information may create or it produce more number of data. And next is the IoT and edge devices, where it can be considered as sensors, cameras and wearable devices. And finally, every time I am saying about the log information, that it will be generated by the application and services, either by the APIs, cloud services and web apps. So whenever any user or the managed device putting a request, automatically it will be going ahead with this zero trust architecture integrated with FL, Federated Learning, because it's been managed by the different organization or different client with set of rules and policies. So based on the policy enforcement, all the data whichever available from the FL, it just produces back to the end user with the user request and the device request. So we are having a different organizational chart. Either it can be the organization, either it can be the medical field, either it can be the industrial thing, and finally we are having a cloud data structure where local data, it will be having their own private data within their organization based on the local training. Either if it is the industrial model where they will be retaining their original data within themselves, they will be providing only the necessary information to whomsoever needed. So it will be provided to the aggregation server. So whenever any end user at the user and devices, if they want a request based on this zero trust policy engine, so it will look for the policy enforcement. Based on that only the data will be provided to the end user. So this is how the zero trust architecture. So without any authentication principle, any data will not go out. So this is how it works. Zero trust architecture integrated with FL. Yes, so thus we are ensuring that it is secure, privacy preserving, collaborative cybersecurity future. So what are all the benefits? If it is not trusted, it will not get verified. If it is not trusted, it will not get verified and the data will not get released. And it will provide only the least privilege access. Whoever at the authentication entity, whoever authenticating themselves, then only the access will be given at this FL model. And secure collaboration, privacy will be preserved, and stronger cybersecurity environment. And this is not okay, collaborative cyber threat intelligence. And coming to this case studies, so far we discussed application. If I want to list, intrusion detection, malware, UEBA, user and entity behavioral analysis, ransomware, these are all the applications we discussed. And application environment we discussed, cloud, IoT, edge and zero trust architecture. Now we are getting into the case study, that too with respect to the federated learning, how it is going to work out. So, and its emerging research trend. These are all the case studies. With respect to the healthcare security, banking and finance, we didn't touch this banking and finance so far, but I just given you one kind of example. If you want to pull down a market of any kind of grocery store, or if you want to pull down a market of any bigger entity, a grocery store, example like a D-Mart, if you are just putting an attack and making the server down for a day, there will be a lakhs and lakhs of loss may happen. This is a kind of a banking and finance. There also the security feature necessarily added up, and we are just witnessing the grocery store as a shop, as a fun element, but basically they are maintaining same kind of architecture whichever we saw in the diagram. So if we are getting into the D-Mart, we do not know how the security element will work. So we do not know how the CCTV works. 24/7 they will be monitoring, and meanwhile their financing transactional communication will be very much stronger. They will be having the dedication connectivity. So these are all the things which we need to understand with respect to the banking and finance. And there is another case study, critical infrastructure production. So that is kind of another important aspect which it is basically considered for a corporate agencies, critical infrastructure. So for any like you may witnessed in some bigger corporate agencies where safe assembly point, or sometime we may witnessed sometime where emergency evacuation plan. So these are all the critical infrastructure protection. And finally, cloud virtual machine protection. These are all the emerging research trends which are all can be listed as case studies. Already we discussed a lot with respect to the healthcare, banking and finance, critical infrastructure I just mentioned, cloud virtual machine we already discussed. And coming to this comparison between traditional and federated learning, where so far we discussed different aspects with respect to the application or the application environment. So basically coming to this data storage, for traditional ML, as I mentioned, it is going to be centralized. Even at the first slide, I mentioned centralized machine learning, where the data will get stored up in a centralized manner, where the raw data will get stored up at the local device, where the raw data, if any kind of migration to be happened between the local server within the organization, with respect to the traditional machine learning, the centralized data, there may be possibility of high risk factor and leakage. And coming to this federated learning, every time we discuss in different aspects so far within the slide, where it maintains the data within the local devices. It will not get saved whenever we are sharing with the aggregation server. So it will not shared or shared with any other aggregation server. It will be maintaining at the local device. Local training model will effectively handle the data, and it provides only the parameter and paradigm which are necessary for the aggregation server. That's what at federated learning they mentioned as a local device. Privacy, I already discussed, it is very low, and at the FL it is much high. Data sharing, raw data, here only the model updates. I just mentioned about paradigms and parameters. Communication, high data transfer, even at the middle of the slide I mentioned bandwidth. Bandwidth consumption is high at the traditional machine. So even we might all heard, or we might have realized, for running a machine learning model, it may take hours of time at the background, at the cloud server. So whenever we are requesting for any file, it takes much time. Sometimes it may be saying to us, you wait for a long time, then only the data will be fetched up. This is what the data will get loaded, and the communication overhead will be the high data transfer for traditional machine learning. For federated learning, optimized parameter exchange, only the necessary data will get shared up whenever it's been necessary. Regulatory compliance, it is much difficult, here it's much easier, because the last diagram, if you are remembering, zero trust architecture, where we might witness the zero trust policy policy engine were generated over there, where it's been compliance with industry standard, or it may be compliance with the particular organization standard, whatever the rules and regulation which be framed and automatically will be maintained. That's what the regulatory compliance is much easier at the FL, because at the starting points itself or the model training itself we can apply that regulatory compliances. Scalability, it is moderate. Here we can scalable up to the head. This is high. Cybersecurity suitability, it is limited and it is excellent. So this is the comparison between traditional and federated learning. So here I want to discuss.
Actually, sir is well versed in forensics, digital forensics. So he trained some police officials. Also, University of Madras, he handled some classes, I know. So maybe you can give some.
Yeah, I
insight.
can. Yes, thank you. Thank you. So this is the part where the research topic we are focused upon, as because the topic which was proposed is a federated learning. We went again with respect to the machine learning, and apart from that, if I want to say, as our fellow colleague, where mentioned wireless sensor security is a research area. Slowly, a set of faculty from our team, we got trained with forensic tools. That's what I just mentioned at the middle of the time. If I brought my own device, I might have connected with different set of elements, because we are having many open source tools to handle, to capture the attack. That's what I just mentioned. I can just connect with the router, and within the router, what are all the deduction count. So basically the tool name called wireless network watcher. So if you are downloading that wireless network watcher, you can understand, and registry scanner, forensic toolkit imager, full toolkit imager. These are all the different set of open source tool. Apart from that, licensed tools also we can handle. There are many licensed tools. I can list down Windows Lifter, Windows Imager. These are all the things. And if possibly I can share the names within this PPT itself at the end as case study. So based on that, these are all the term which it is coming from the forensics. So even I need to check the day schedule from the sheet whether any forensic title added, sir. No. So this is one of the emerging area, forensics. So this is something which it is necessarily for the research. That's what we just discussed. So forensics, it has its many branches. So where we can categorize the forensics as browser forensics, mobile forensics, disk forensics, IoT forensics, particularly if I want to say IoT forensics. So every branches, it has its drone forensics. Drone forensics is the current generation standard where many opportunities may arise. Drone forensics, that's because everywhere this drone, even we are witnessing a drone light show as well sometime, and drone attack as well. That's what drone forensics also emerging nowadays. These are all the terms which you all need to know. So every branch has its own secured mechanism. Particularly if I want to mention for mobile forensics, where the tool, different set of tool which it is available. The high-end tool, I can mention the name Celebrit, Cellebrit. Celebrit, it's the Italy-made tool. If you are searching for the Celebrit tool, it can capture your complete mobile phone within some moment of time. Only thing, your mobile phone needs to get rooted. So the replica or the Indian version was developed and it's been owned by CDAC. CDAC is a government organization within our Indian nationwide. So they developed and they are owned the replica of the Celebrit, the mobile forensic toolkit they already made. That is mobile forensics, where if your mobile phone got rooted, just through the mobile phone, whatever the URL which you deleted, while the purchase of the mobile phone we can capture. It is nothing but the recovery tool. I am not mentioning about the recovery. So I am just mentioning whatever the browser which you used, from the browser, what are all the URLs which you deleted, right from the purchase of the mobile phone, everything will be listed. And whatever the SMS which you are deleting every day we are deleting the SMS. Every information can be fetched out. Again I am saying it is not recovery tool. It's a mobile forensics. I am just saying different set of future. Apart from that, what are all the SIM users, operator user? This is what actually the mobile forensics. And meanwhile I can say browser forensics. So browsers, we are having a different set of browsers in our mobile phone, including Chrome, Mozilla, Safari, Opera. So these are all the different browsers. So every browser, they are having a different set of features which we may not get witnessed or we may not used. So this browser forensics helps you to understand those in a detailed way. So we can take up Edge browser. I forgot to say about the Microsoft also. Edge browser. That is the old and traditional one. So every browser having a different set of information, where we all basically witnessed this saving the password. We do not know how the search engine works, how the cookies working. Every time we are giving the accept all cookies and other thing. So there are such informations which is coming under browser forensics and disk forensics. So these are all different branches I am trying to say. This is only the research aspect. Federated learning is a research aspect with optimization algorithm to making the environment secure. That's what I am trying to say. With optimization algorithm, the model training, the model employed, the model needed the entire skeleton now. Entire skeleton in the sense some kind of a front-end application. Then only this model works. But what I am trying to say is this is completely different aspect with respect to the cybersecurity. Where the disk forensics, where we are using SSD, your own laptop. We are using HDD, where it's been given with HDD. So what are all the data can be captured? So far we might, whenever I am saying SSD and HDD, we all can understand that only the data, either system information, either whatever the program files or apps which are installed within the PC or personal computer or SSD. Those are all the data which we can understand, but we do not know the registry information, which we do not know the cache information, and there are many upgradation happening in the technology advancement, where why this RAM speed always getting increased? Have you ever like identified or whether we are understanding why this always this RAM speed we are increasing? So there are some kind of a terminology or where there are some kind of understanding which we need to know basically. That's what even our mobile phone nowadays, if I am asking you to buy 4 GB RAM mobile phone, we will not purchase. Why it is so? Because of this technology advancement and app usage. So far we discussed about the log file app usage. WhatsApp, we can take up the meta database. Meta database, the server is something they are scaling up every day with different aspects. They are releasing different features. Now, have you ever witnessed using the same meta database, WhatsApp can be used as Gmeet? Have you ever witnessed? The future enabled already. How we are having this Gmeet call, some 50 to 100 participants we are having. Same feature enabled in WhatsApp now. Many of them may receive the update, we might not install that, or we may not accepted that. If you are accepting it, automatically it will be showing. Where I can make out a call, I can enable a call. In the call, I can add up some 10 members. Almost like Gmeet, how we are connecting the Gmeet call, similar way Meta also they enabled. These are all the things where this Meta were working every day. That's how this RAM speed also getting increased. It is not that much sufficient. Even our laptop. So we may have 4 GB, 6 GB RAM laptop, 8 GB RAM. Nowadays 16 and 32 is the sufficient one. So where these data resides basically in the disk only. That's what I'm trying to say, disk forensics. So where this information getting stored up? At the disk. Where this information will get stored up? At the registry. SIM cache memory, and PC information, and dump list, RAM dump. So these are all the data which we all. So these are all the area where we may all not witnessed. So this is about the disk forensics, where here also we can fetch the data in a different aspects, in a different artifacts I'm trying to mention. So these are all the area which we are all experts, some team members. Among with me, some team members are all experts, where we got in-house training from CDAC and we are handling the tools. So just look into this forensic tools possibly. It is having a different dimension possibly. So that's, I tried explaining about that, and I am concluding this research topic which I were intended to complete for today. I can complete today. This is how the completion. Federated learning represents the transformative paradigm enabling privacy preserving collaborative artificial intelligence for modern distributed cybersecurity application across diverse organizational environments globally. And meanwhile, organizations can collaboratively improve cyber threat detection while maintaining confidentiality, regulatory compliances, complete ownership of sensitive cybersecurity information successfully, integrating FL with advanced technology like zero trust, graph neural network. This is one important topic. I'll be coming up with this graph neural, blockchain and post-quantum cryptography enhances future cyber resilience. Continued research addressing scalability, trust management, communication efficiency, explainability and robust aggregation will accelerate real-world federated learning adoption worldwide. So this is already in use, this FL. That's what I just gave you different set of example. And still this to be scaled up. And finally, thanks for giving me the attention, and any questions you can go ahead. Thank you.